The James Webb Space Telescope was launched with a bold purpose: to look further back in time than humanity ever has, to witness the very first stars flicker into existence, to trace the birth of galaxies, and to search for new worlds circling distant suns. It was designed to answer the deepest questions we've carried for generations. But what happens when the answers it gives us don't just solve mysteries, but instead unravel everything we thought we knew? What happens when the most advanced telescope ever built reveals objects that, according to our physics and our models, should not exist at all? That is exactly what's happening now. Webb has uncovered two discoveries that defy expectation. One is practically in our own cosmic backyard, a strange planet that seems to survive in a place where no planet should. The other lies at the very dawn of the universe, a collection of galaxies that appear to have grown up far too fast, far too soon, breaking our timeline of cosmic history. These are not small anomalies. They are cracks in the story of the universe itself. And as astronomers race to understand them, we may be standing at the edge of a new revolution in science. Let's begin close to home. Just 4 light-years away lies Alpha Centauri, our nearest stellar neighbor. This system contains 3 stars, 2 that are very similar to our own sun, and a smaller red dwarf called Proxima Centauri. Because it's so close, Alpha Centauri has always been a prime target in the search for planets. We already know that Proxima hosts worlds, but the bigger sun-like pair has remained strangely empty. The reason is gravity. Imagine 2 enormous suns locked in a tight orbit around each other, their gravity tugging and twisting violently. Conventional theory said that such chaos should prevent planets from ever forming there. Any fragile disk of gas and dust, the raw material of planets, would be ripped apart. And if a planet somehow did form, the pull of 2 stars would most likely fling it out of the system. For decades, Alpha Centauri was considered too hostile for a planet to survive. Then came Webb. In August 2024, astronomers pointed its instruments at Alpha Centauri A and used one of its most advanced tools, a coronagraph. This device acts like a shield, blocking the glare of the star so faint objects around it can finally be seen. The data revealed a speck of light, tiny but persistent, more than 10,000 times dimmer than the star itself. After months of careful analysis, the team announced they might have found a planet. The evidence suggested a gas giant, perhaps the size of Saturn, orbiting at a distance comparable to twice Earth's orbit around the Sun. Such a world wouldn't be habitable itself, but it could host large rocky moons, and those moons could potentially support life. If confirmed, this would be a historic find, the nearest planet ever directly imaged around a sun-like star. But then came the twist. When Webb looked again in early 2025, the planet was gone. The light had disappeared. Was it an error? A glitch? Some scientists thought so. But simulations told another story. When researchers ran millions of orbital scenarios on supercomputers, they found something extraordinary. In many possible orbits, the planet could have slipped behind the coronagraph's light shield, hiding it completely during the second observation. In other words, the planet may not have vanished at all. It might just be playing a cosmic game of hide-and-seek. The evidence still points toward its existence, but the final verdict will require more observations. If it is real, it forces us to reconsider everything we thought about planet formation in binary star systems. What we once believed impossible might turn out to be far more common than we imagined. While one of Webb's eyes was locked on our nearest neighbor, its other was staring across billions of light-years toward the very dawn of time. And there, too, it found something shocking. According to the standard model of cosmology, the universe after the Big Bang was a quiet, featureless sea of matter. Over hundreds of millions of years, gravity pulled tiny clumps together to form the first stars. These stars gathered into small, primitive galaxies, which slowly merged and grew over billions of years into the vast spirals and giants we see today. The process was thought to be gradual, predictable. But Webb's infrared vision, designed to capture the faint glow of the earliest galaxies, has revealed a different story. It has seen massive, mature galaxies appearing just a few 100 million years after the Big Bang. Some contain red, ancient stars, galaxies that look like they should be billions of years old. but instead exist at the cosmic dawn. It's like walking into a nursery and finding not babies, but fully grown adults. How could this be? Some scientists suggest that the galaxies might not be as massive as they appear, that black holes at their centers could be distorting the measurements. But even with that explanation, there are still far too many of them. The young universe seems to have built galaxies faster and more efficiently than our models allow, and the mysteries don't stop there. Webb has also spotted quenched galaxies, systems that stopped forming stars entirely while the universe was still in its infancy. According to theory, this was supposed to be the era of peak star formation. Yet, here are galaxies that burned out almost as soon as they began. Perhaps the most startling case is a galaxy catalogued as JWST 13-1, observed just 330 million years after the Big Bang. At that time, the universe should have been cloaked in a dense fog of hydrogen gas. This fog should have blocked the very type of light Webb detected from that galaxy. Yet somehow, the galaxy's light pierced through. The only way this could happen is if the galaxy had already carved out an enormous bubble of clear space, hundreds of thousands of light-years wide, around itself. For such a young galaxy to create such a vast clearing defies explanation. Some theorize it hosted the universe's first generation of stars, population 3 stars, monsters far hotter and more massive than anything alive today. Others suggest one of the earliest supermassive black holes was blasting energy outward, clearing the fog. Either way, it means the process of cosmic reionization, the clearing of the early universe, was faster, more violent, and stranger than we believed. So, what do these two discoveries tell us? A possible planet in Alpha Centauri that challenges our understanding of planetary formation. Ancient galaxies that defy our models of how the cosmos grew. One is a question of mechanics, the other a question of history. Together, they remind us that the universe is more inventive, more unpredictable, and more mysterious than our theories can contain. Some scientists call this tension, the gap between what we expect and what we observe. But tension is not a failure. It is the birthplace of discovery. The ghost planet of Alpha Centauri and the galaxies that matured too soon are not dead ends. They are invitations, clues pointing us toward a deeper truth about the cosmos. The James Webb Space Telescope was built to uncover our origins, and in its breathtaking, bewildering images, it's doing just that. It is showing us that for all our knowledge, the story of the universe is still unfinished. We are only reading the opening chapters, and the rest, the twists, the surprises, the revelations, are still waiting to be discovered.